All right, guys. Midterm study guide for 1500. The purpose of this video is try to get you prepared to take the midterm, which is coming up in the next week. Um, I don't know about you, but I've taken a lot of classes before, and I found that sometimes I may take an exam and get a poor grade, and it wasn't as much that I didn't study or wasn't prepared for the exam. I just didn't study the material that the professor thought was important, or at least most important, or at least was on the test. So that's the purpose of this. The purpose is to, let me grab my calculator here. The purpose is to kind of give you an indication of the types of problems that you'll encounter, and go from there. So, guys, let's get busy. It's going to be a pretty lengthy video, I would assume. I think I have 6 or 7 pages here, so we'll get through it as quickly as possible. All right, gang, first question. Results from a recent report indicate that 82% of U.S. adults owns a cell phone. I would have thought it was higher than that, but if 350 U.S. adults are selected at random, then what is the probability that less than 170 owns a cell phone? Well, guys, ultimately what you get into is you get into what we've talked about before. We get into 170 or less, and we have to use exact these limits, which should be no surprise to you at all. And since we're going to the left at 170, we're going to use 169.5. Now, guys, remember the mean for this distribution is n times p, and the standard deviation for this distribution is n times p times 1 minus p. What we would do here to work the problem, let me get this where the glare isn't so bad, is we want to use our normal CDF. And I'm not going to teach as much in this as I have in other videos. We're just going to work the problems here. So what would go first is negative E99. What would go next is 169.5. What would go next is n times p. So guys, n was given in the problem. It's 350. Times p, also given in the problem. That's the 0.82 up here. And the standard deviation, standard error in this case, is the square root of n times p times 1 minus p. Now I can do this in my head. I can see that 1 minus 0.82 is 0.18. If you can't do that, it's not a big deal. Just get that figured out before you start the problem, because you're always going to need 1 minus p in these problems. So, guys, the answer is 0. It's not going to happen, and it kind of makes sense that it wouldn't, because if 82% of the population owns a cell phone, 170 out of 350 is 0.5. So to think that you're going to get a sample that only half, less than half, owns a cell phone doesn't really match with the population parameter of 0.82. So the fact that we get a probability of 0 here, and it doesn't really mean that it couldn't happen, it just means that based on the rounding of the calculator, it would be 0.0000. It goes out so far that the calculator just rounds it to 0. It could be something like, 9.82 times 10 to the negative 85th power or something like that. But within reasonable rounding, we just assume that it's not very, very likely to happen. Now, in this situation, you're given the proportion, so we don't have to use this real limit that we talked about in a previous video. So what we're talking, and again, before I get into that, notice that what we're testing, 0.84, is much closer to what describes the entire population of 0.82. So we're not expecting an answer of 0 in this situation. So again, to give you an indication of what's going on, we have 0.82 as the well, 0.82 times 350 is the mean. So we're wanting to know 0.84. Now, or higher. Well, in these situations, we work these differently, and we have a different standard deviation and a different mean, a different standard error. So the mean in these situations is just p, and the standard deviation in these cases is p times 1 minus p over n. If you're looking at a count, this is one of those things, I'll go ahead and tell you, you get to bring in a 5-inch by 8-inch note card when you take your midterm. So this might be one of those distinctions that you would want to put on your note card. If you're looking at the probability of higher or lower, more than, less than, whatever it may be, of 170, so a count out of n, then the mean and standard deviation are given in this problem. But if you're looking for a particular proportion, the mean and standard deviation are given in this problem. Okay? So what we would do here, we want 0.84 or higher, so we're looking at 0.84 and above. So in the calculator, we would have 0.84 up to E99. The mean in this situation is 0.82. And the standard deviation is the square root of 0.82 times 0.18 divided by the sample size, which is 350. Now, let me go ahead. Let's just go ahead and get the answer. The answer would be 0.1605. 0.1605. Is it 15 or 50? My bad. 0.1650. The dyslexia kicked in there briefly. So, guys, again, come into your midterm prepared that you'll probably have one like this, where you're actually given a count out of the whole, and you'll probably have a problem like this. I haven't made out the exam yet, so I can't tell you for sure what you're going to have. But these questions came from a previous exam, so midterm exam, so it makes kind of makes sense that you may see one of each of these. And if you're given actually the sample proportion, then the mean and standard deviation are given this way. Okay? All right, number 2, find the value of z such that the area that lies between negative z and z is 0.5984. So guys, I think a picture always kind of helps. Remember for z, that the mean is equal to 0, so smack dab in the center of the distribution, we'll have 0. So to the left of that we have negative values, and to the right of that we have positive values. Well, the way this problem is setting up is a 0.5984 of the area is between those two numbers. All right, so the very first thing I'd want to do is I'd want to find the area that is missing. And I know that the total area, this part plus this part plus this part, has to be equal to 1. So I can go 1 minus 0.5984 and get 0.4016. Now that's the area of this plus this. So it should make sense that I need to take that and divide by 2 to get 0.2008. So 0.2008 goes right there, and 0.2008 goes right there. Now, this number plus that number, and you can check me on it, will add up to 1, which is the area under any probability distribution. In this case, we're looking at a normal distribution. Now, what I need to do, I know if this is negative, for example, 1.69, that this one has to be 1.69 because it's symmetric the way that we've distributed this 0.5984 equally on both sides of the zero. So if I can find one of these, I'm going to know the other one. So I'm going to focus on this one right here, and I'm going to use inverse norm, because that's the calculator key that we use to find a value from a distribution that has a particular part of the area under the curve to the left of it. So I want 0.2008 to the left of this value. I have a mean of 0, and I have a standard deviation equal to 1. So the z-score there is negative 0.84. So guys, I know this one has to be positive 0.84. Now, go back to the answer, or I'm sorry, to the question. Find the value of z such that the negative of that and the positive of that creates 0.5984 both between. So guys, my answer is 0.84. Now, you can test that out if you want, and I probably would if I were taking an exam. I would go to distribution normal CDF, and I would go negative 0.84 to positive 0.84 with a mean of 0 and a standard deviation of 1, because we're looking at standard scores. And I would expect to get an answer very, very, very close, within reasonable rounding, to 0.5984. Well, I get 0.5990, which is only 6/10,000ths off, which I'm pretty comfortable with that. Number 3, which measure of center, the mean or the median, would be appropriate for describing household incomes? Guys, this is a no-brainer. This deals with money. So you're expecting a skewed distribution, a positively skewed distribution, and in those situations, we refer to the median over the mean. When we have bell-shaped and symmetric distributions, we refer to the mean. When we have skewed distributions, which almost always accompany variables that deal with money, we have the median as the best and most stable measure of center. Determine if the numerical value describes a parameter or statistic. Remember, guys, parameter deals with a population, statistic deals with a sample. So 23% of U.S. voters with advanced college degrees intend to vote for Donald Trump. I actually got that. I actually didn't make this up. In the 2016 presidential election, I actually did find this. Well, guys, this is making a statement about a broad group, all U.S. voters. So because of that, this would represent a parameter. Now, what if it said that a poll was taken of 1,000 U.S. voters, and 230 say that they're going to vote for Donald Trump, and they have advanced college degrees? Then that 230 out of 1,000 would be a statistic because it's representing a sample. We know there are more than 1,000 U.S. voters, so that would be a statistic. All right, the variable that is categorical or qualitative. So we're looking at the one that lumps people into groups. So, guys, the very first one we get is political party. Why wouldn't the others be? Well, ACT is clearly quantitative, not qualitative or categorical. Height in pounds. All right, that's kind of goofy. I think that should have been weight. And the number of TVs owned is also a number. So these three right here would end up in numbers, which are quantitative and not categorical. All right, number 6, IQ scores are normally distributed with a mean of 100, standard deviation of 15. So we can say that IQ's normal distribution 100, 15. What is the probability that a person who is selected at random has an IQ lower than 75? So guys, what we're doing here, we have 100 in the middle. Numbers to the right are bigger than 100. Numbers to the left are smaller than 100. Our focus for this particular problem is on 75, and we want the area to the left because the problem asks lower. So guys, if I come all the way to the left as far as I can, I go all the way to negative infinity, which in the calculator is negative E99. So guys, this is going to be an easy problem. Normal CDF, negative E99, up to 75, comma 100, comma 15. So 0.0478 would be our answer there. Now, next thing says, next problem, part B, says if n equal 15 people. Now, when I see 15 people, I know that I am looking for a measurement that combines those 15 scores. So I'm going to add up those 15 scores from those 15 people, add them by 15, and I'm going to get the sample mean for those 15 people. So what does this make me think? Well, I've got to change the standard deviation to sigma over the square root of n. Up here, I didn't have to do that. I used the standard deviation just as it was given, because for this, I'm saying that a person. That a person indicates to me that we have n equal 1. Well, we don't have n equal 1. Once we raise that sample size bigger than 1, then we have to adjust the variability in our distribution by looking at the standard error and not standard deviation. So what's going to happen here? We went lower than 92. So it's still going to kind of play out like this. We're going to go from negative infinity up to 92, but we have to make the adjustment of the standard error instead of the standard deviation because of the sample size. So boys and girls, negative E99. Up to 92. Mean is 100. The mean doesn't change in sampling distributions, but this okay, the standard error does. Okay, now I really don't like the way this played out. I wish I'd chosen a sample size other than 15. Because in this situation, your sample size is the same as your standard deviation. This is not the case. Let's say, I mean, that could have been 35 people, and I wish actually I'd made it that way. It just so happens that in this unique problem, that our sample size is the same as our standard deviation. Guys, that won't happen very often. So if this sample size was, for example, 32, then we would put a 32 right here instead of the 15. All right. So 0.0194 is the answer to part B. Part C, what is the probability that a person selected at random? Person who is selected at random, what do I think? It's one person, n equal 1. So guys, I use this standard deviation. So I need between 98 and 108. This is going to be an easy problem. All right, so 0.2561. All right. I don't think this is going to take quite as long as I thought, or maybe not. Maybe so. Calculate the standard score. Guys, what standard score mean? By now, you should know when you see that. You're calculating a z-score. The formula for a z-score is to take the raw score minus the mean over the standard deviation. So we want to calculate the standard score for an IQ of 120 minus the mean of 100, standard deviation 15. We're still using IQs from the previous problem. So when I put this in my calculator, what I just need to make sure is that I don't do something goofy and mess up the order of operations. Let me show you. This is the correct way to do it. so it's 1.33. I've seen students before do this and they get it wrong. Well, what happens? Your calculator is what's called order of operations smart. So it's going to be smart and do the division first and then subtract this part from the 120. That's not what you want. You want the numerator calculated first and then divide by the 15. So this would be the wrong answer, 113.33. Correct answer, 1.33. Now, part E says, what is the minimum IQ required to be in the top 12%? Well, in the distribution of IQ scores, the top is up here. So there's some score right here that divides the top 12% with the bottom 88%. Again, when you divide this distribution into 2 or 3 or 4, whatever number of parts, this part plus that part has to add up to 100 or 1, depending if you're looking at decimals or percentages. So guys, what I need is I need an IQ score that has 88% of the distribution below it. Why do I focus on the 88 instead of the 12? Because that's the way the calculator is set up. So gang, I need to go into inverse norm. 0.88 goes first. I have a mean of 100. Standard deviation 15. So I need an IQ of say 118. To be in the top 12%. What IQ represents the 80th percentile? What's percentile ranking tell you? Percent below. So guys, in this distribution, there is some score that has 80% below. Well, guys, I don't have to do anything like I did up here in terms of creating a new number. 12 was given, 12 was here. I had to create this because that's the way the calculator requires the entry to be. I don't need to create anything because I've got percent below. So I'm going to go second function entry. And all I need to do is change that from 0.88 to 0.80. So I get 113. So guys, if you have an IQ of 113, your IQ is at the 80th percentile. So you might conclude that of every 100 people that you meet on the street, on average, randomly, that your IQ is higher than 80% of them. Okay, whatever. I think you know by now how I feel about IQs. I think I told you in a previous video, I think I've taken, I don't even know how many I've taken, but I know it's close to 10. And I've yet to get the same IQ on any score. It's the same IQ score on any test. So these things fluctuate not only from person to person, but within the testing environment and within the person. So what's my IQ? I have no idea. Somewhere between 0 and 200. So in a class of 10 students, grades on a test are summarized in the following distribution table. What is the mean score? So let's make sure, first of all, that I have a sample size of 10. So I got 6 and 3 is 9. So I do have 10 students. 4 of them scored 100. 2 of them scored 98. 3, and so on and so forth. So guys, I know that these scores right here have to add up to 400. I know 98 times 2 is, what, 196. 3 times 91 is 273. And 1 times 82 is 82. So the sum of the scores, if I have 4 grades of 100, those scores had to add up to 400. If I have 2 98s, then those scores had to be 196. So I can find the sum of all these scores just by adding these numbers. And I get 951 as the total score. If I divide by 100, divide by 10 students, I get a 95 95.1. Guys, I hope you guys do that well in the midterm. I say it all the time. I love giving A's. All right, now another way to do that is kind of one-stop shop. I could have, instead of multiplying these out this way, I could have gone in parentheses 100 times 4 plus 98 times 2 plus 91 times 3. Got to put this in parentheses for obvious reasons. And then I only had 182. So I still get the same 951 sum, but I've got to divide by 10 to get the average. So again, 95.1. So whichever method floats your boat, go for it. All right, a college basketball player has played 10 games and is averaging 15.7 points per game. Guys, I can go ahead and take that information and tell you for sure that the sum of that person's scores had to be 157. I can now subtract out what I see. I see a 12, a 13. I see a 20. I see a 21. I see a 19. I see a 3. I see a 14. I see an 11. And I see a 33. This person plays about like me, very inconsistent, or played like me. So guys, in the other game, he or she, well, it says a she, had to score 11 points. So guys, again, the average is equal to the sum of the scores over n. We can multiply both sides by n, telling us that the sum of the scores can be found by taking the sample size times the mean. Well, our sample size here is 10 times the mean. So here I have 10 times 15.7 is 157. So I know these 10 scores have to add up to 157. Well, I've only got 9 of them, so the missing score has to be what it takes to get to that sum of 157. All right, gang, we have the distribution of average property damage caused by tornadoes. You would expect, a lot of damage to include 0, hence making that bar higher. So the distribution would be positively skewed. Would you expect the mean to be greater than the median? Now let me go back to this. A lot of times students get confused here. Always remember that these histograms are embedded in this rectangular coordinate system. To the right are positive numbers, to the left are negative numbers. This histogram sits in here someplace. When you smooth that out, whatever direction the tail is going toward the positive numbers, going toward the positive numbers to the right, that defines the skewness. If you have the high bar here and you're going this way, then you're going toward the negative numbers. Your tail is. So that would be a negatively skewed distribution. Guys, in positively skewed distributions, the mean will always be greater than the median. And I put up a video a few weeks ago describing that in a lot of detail. All right, use the given data to answer the questions. Calculate the 5-number summary. Guys, I'm going to use the calculator here, so I'm going to go to Stat. And I'm going to go to Calc, one variable stats. Shoot, I'm not going to do that. I'll tell you what, let me get out of there. Okay, so Stat, Edit. I'm going to go to L1. First thing I'm going to do is clear out the information. And then I'm just going to type 0, 40, 72, 94, 137, 176, 186, 239, 267, 310, 505, 742, 837, 1034, 1286, and 3000. Now, if it were me, I'd go back. If my grade were at stake, I would go back and check these. So 3000, 1286, 1034, 837, 742, 505, 310, 267. So it looks like I got it right. Next thing I would do is go to Stat. I go over to Calc, one variable stats. I got my information in L1. So my 5-number summary is found at the bottom. The 5-number summary consists of the minimum value, which in this case is 0. Q1, which is 115.5. The median, which is 253. Q3 is 789.5. And the max is 3000. All right. Gang, what is the percentile ranking for 505? Well, 505 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 11, 12, 13, 14, 15, 16. So it has 10 scores out of 16 below. Actually, I should count the 505, so it should be 11 divided by 16. Because percentile ranking is technically the percentage of scores at or below the given score. So we would be at the 0.6875, which rounds to 0.69. So we'd be at the 69th percentile. The 5-number summary, IQR isn't included, minimum Q1, median Q3, so I guess that would be B. All right, the histogram represents the height of the gold medal winning high jumps for the Olympic Games. The median winning jump must fall in the interval. Well, what we need to do here is find out our sample size. So I know between 70 and 75, I have 15 jumps. And between 75 and 80, I have 40 jumps. Between 85 and, between 80 and 85, I have 10 jumps. Between 85 and 90, I have, we'll call that 25 jumps. And between 90 and 95, I had 10 jumps. So I can, 80, 90, looks like 100, I'm pretty sure. 15 plus 50 plus 35. So I have 100 jumps. Now, if I've got these numbers arranged from the lowest to the highest, and this is my first one, and my second one, my third, and I've got them arranged from 1, 2, 3, 4, 5 all the way up to 100. And these are the numbers that are in the first place, the second place, the third place, and the highest would be the 100th place. If I can come in and find the number halfway, which would be in the 50th position, then I've got my median. Well, guys, I know that 15 of those are right here. And I know that 40 of them are right here. So my first 65 numbers are between 70 and 80. My first 15 numbers are between 70 and 75. So my 16th, 17th, 18th, 19th, 20th, all the way up to my 65th falls in this range right here. So guys, my 50th number has to fall in the range of 75 to 80. Are we having fun yet? Number 13, the box plots that are provided give commute times for a random sample of 100 residents of North Carolina and New York. Which state has the highest third quartile? Well, guys, the third quartiles deal with this line right here, the top of the box. So clearly New York has the highest third quartile. Which state has the highest IQR? Because IQR is the length of the box, the difference between the Q3 and the Q1. So clearly this has more area than this, so New York again. Which state has the most overall variation? That would be the overall variation would start from the lowest to the highest. Clearly, New York wins again. All right, scores on SAT are normally distributed with a mean of 1026 standard deviation. .209. ACT is another nationally recognized score that competes with SAT. The ACTs are also normally distributed. 4.8. Which ACT score, oh, that's kind of crazy. Which ACT score that would, okay. All right, which ACT score would correspond to an SAT of 750? Well, the first thing I would do is I would find the location of the 750 to the other SAT scores. So I would find the standard score. So it is negative 1.32 standard deviations below the mean. Now what I would do is I would come over to the ACTs and I would let that be my z-score. And I would find the ACT. Now, you guys, we used to put an X right there, but in this situation, the variable's defined. It's ACT, so I just put the ACT. First thing I would do is multiply both sides by 4.8. Now what I can do here, since I've got the 1.32, or rounded off, but I've got the entire z-score there, I'm just going to hit multiply and multiply by 4.8. Now the next thing I need to do to isolate the ACT is clearly add 24.4 to both sides. So guys, that would correspond approximately to a 14. Now the 750 was below the mean, so we would expect an ACT score to correspond to it that is also below the mean. Both of these scores, 750 and 14, are approximately 1.32 standard deviations below the mean. Guys, I've got 2 pages left. Shouldn't be much longer. All right, number 15. This is a box plot of verbal GRE scores from applicants to a California state college. Approximate the value of the third quartile and the IQR. Well, if I bring this over, I'm going to approximate Q3 approximately 600. Now, we also want to approximate the IQR, and don't forget the IQR is Q3 minus Q1. Well, I know Q3, its approximation. Now, if I come in here and get the approximation for Q1, what do you guys call that? 375, 370? So I'm going to approximate it at 230. Now, let me tell you something. Yeah, what if you got 225? What if somebody else got 240? We approximated 370 a little differently. That's okay. What I would do, your exam is going to be multiple choice. So I would have probably the following. I would have like 150, 230, 370, and 500 as the answers. So if you miss this, it's just, I mean, you would really have to get off a wacky in your approximation and do something really goofy there. You know, and let's say again, you approximated this to be 380 and you end up with 220 and you come over here and you don't see a 220, but clearly 230 is closest. And again, come back to the details of the problem, approximation, okay? To completely specify the shape of a normal distribution, you must know what two values. You must know the mean and the standard deviation. Number 17, the mean of a normal distribution is 300. All right, let's go ahead and just... But the standard deviation is unknown. All right, that's cool. Of the answers provided, the only z-score that could correspond to a score of 380, which is above the mean, is what? Well, guys, it has to be the positive z-score. Number 18, what value of z has area 0.0542 to the right of it? Guys, remember, means, z-scores have mean 0, standard deviation 1. So 0.05 is way up here because this is 50% below. And we want 0.05. So it's going to be a positive z-score. So we want the z-score that has 0.0542 above it. Well, guys, inverse norm is the key we're going to use. But inverse norm requires you to know the area below the curve. So I'm going to have 1 minus 0.0542, comma 0, comma 1. I don't even think you have to type in the 0, 1. But just to be thorough. So 1.61. Now, let's say you got a little bit of time left. You're getting ready to submit your assignment, or I'm sorry, your exam, and you're kind of curious if that's the right answer. Well, you can check it out. We could go to normal CDF and request the area from 1.61 up to E99, because we want area to the right. For standard scores, does it mean a 0, standard deviation 1? And if we got the right answer, what we get on our calculator should be really, let me get it to where you guys can see it, should be really close to the 0.0542. But we get 0.0537, which is reasonably close, considering rounding. I'll tell you what I'm going to do. For those of you that are watching this video, I'm going to reward you for watching this video. When you turn in your exam, so let's get all dramatic here, okay? I don't know if I can get a sheet of paper. Your exam is going to look something like this. It's going to say midterm, math 1500, name, good luck, yada, yada, yada. Question number 1. If you will come up here in the right corner and put the answer to this problem. So guys, put that on your note card. 1.61. I will give you 5 additional points on your midterm score. So if you get an 88%, I'm going to add 5%, and you will get a big old fat A on your midterm. All you got to do is give me your name and put 1.61 up in the right-hand corner and circle it, and you'll get 5 extra points. All right? All right, guys, last page. I think there are 20 questions. Yeah, there are. Number 19, what are the mean and standard deviation for the normal distribution provided? Well, guys, you should know that the mean is the value that sits right in the middle. So the mean is equal to 2. And then for reasons I explained in the video, there's a, curve, but then all of a sudden this thing starts to become kind of like a straight line. So if I trace a curve, then all of a sudden kind of a straight line. If I come to the center of this straight line, the straight line part, see, that's kind of straight. Drop down, and that's about at a 5, isn't it? Well, the distance between the mean and that value is the standard deviation. So I would approximate this to be, I have a mean of 2 and a standard deviation equal to 3. So tempting. A lot of students will tell me, well, the standard deviation is 5. Because that's not right. The normal distribution has the mean in the center, and this place right here is the mean plus the standard deviation. So I've got to find to the standard deviation. It's what I add to the mean to get to this location. So I add 3 to get to that location, which is the value of the first standard deviation above. All right, gang, last problem. Gestation periods for women follow a normal model with mean 266 days. Standard deviation 16 days. If a random sample of 35 women are selected at random, then what is the value for the standard error? Guys, the standard error is sigma sub x bar. It's just the standard deviation of the population divided by the square root of n. So our standard deviation is 16, and our sample size is 35. So 16 divided by the square root of 35. So 2.7045 is the answer. Now, guys, on your exam, because it's multiple choice, rounding is not going to be an issue. You would have the answers over here. I would probably have something like 1.4287, 2.7045. C is 3.1698, and the other would be 6.4273 or something like that. So, if you round this to 2.70, you come over here, it's pretty clear which answer is correct. All right, gang, don't forget, when you come in and take your exam, don't forget to put the 1.61 right up here. If you forget it and you get home and say, oh, wow, I forgot, and email me, I'm not going to give you credit. It has to be done when you take your midterm. So put this on your note card as a reminder that if you put 1.61, you're going to get 5 extra points. Guys, good luck. I really do hope that you guys do well, especially those of you that are watching the videos and approaching the class the way that you should and the way I told you at the beginning of the class that you need to. So, guys, have a good one. Take care.